In this episode, we'll be talking about molecular formulas. As I mentioned in the previous video, an empirical formula is the reduced version of a sometimes very large molecule. So you can take that empirical formula and determine what the molecular formula would be if you know the molar mass of your molecule. It's important to remember that a molecular formula is giving us the actual exact atom count of all of the elements in a compound. So we're going to look at an example using the previous empirical formula that we solved with percent composition data. So if you need to, refer back to the empirical formula video before you continue watching. But just as a recap, our empirical formula from that video was C2H4O. And in this question, we have that data still that we're using, but now we're trying to figure out what is the molecular formula of a related compound to this when we do know that its molar mass is 132 grams per mole. So basically what we need to do is figure out how much bigger is this molecule than the empirical formula that I already know. So to get started with that, we want the molar mass of the empirical formula. Okay, so molar mass, remember, is adding up all of the all of the elements multiplied by their subscript. So 2 carbons, 4 hydrogens, and 1 oxygen. So for this compound, we have 2 times the molar mass of carbon, which is 12.01, 4 times hydrogen's mass, which is 1.01, and then we're adding 1 oxygen to that, which was 16. So that's going to give us a total of 44.06 grams per mole for my empirical formula mass. Now I just need to figure out how much bigger is my molecule. So I'm going to take my molecular molar mass, I'm just going to call that MM, and I'm going to divide that by my empirical molar mass. Okay, so our molecular mass was given to us as 132 grams per mole, and then we just found out that the empirical mass is 44.06 grams per mole. When we do that math, that gives us a decimal that's pretty much 2.99, but it's very close to 3. So this is going to be known as our multiplier. This is basically what we need to multiply all of our subscripts by in order to get to the molecular formula. So all we have to do left is we take our empirical C2H4O and basically multiply all of that by 3, which is going to give me a final molecular formula of C6H12O3. And that is how you take percent composition in the previous video to empirical formula, and then empirical formula to molecular formula. And that concludes molecular formulas.